Tripathi, and my topic is type 2 restriction endonucleases. So, restriction endonucleases. So, these enzymes are molecular seizures that cut double stranded DNA molecules at specific points. These are also called restriction sites. These enzymes are found naturally in prokaryotes, primarily in bacteria. So, these enzymes provides a defense against the invading viruses. So when a foreign DNA tries to infect a bacteria, these enzymes recognize the specific sequence and cleave it into pieces to protect itself. So these enzymes cleave the phosphodiester bonds, and nitrogen bases are not damaged at all. It cleaves. The cleaving is predictable and reproducible. That is, if DNA is cut at some specific site, everything every time the enzyme will cut it at the same site only. So the question is, why don't bacteria destroy their own DNA with their restriction enzymes? There is the restriction modification system, the RM system. There is the restriction enzyme R, which cuts the foreign DNA, and there is methyltransferase T, which methylate one of the bases in each strand and protects host DNA from cleavage by the restriction enzyme. Restriction enzyme and its cognate modification system constitute the RM system. So by the RM system, bacteria cuts the foreign DNA without damaging its own. So the awards for the discovery of restriction enzymes. So the Nobel Prize in Physiology or Medicine 1978 was awarded jointly to Werner Arbor, Daniel Nathans, and Hamilton O. Smith for the discovery of restriction enzymes and their application to problems of molecular genetics. So now type 2 restriction endonucleases. So these are the most commonly available and used restriction enzymes in labs or scientific works. These enzymes protect bacteria and archaea against invading foreign DNA, mostly eubacteria. The first type 2 enzyme to be isolated was HIND2 in 1970. So type 2 restriction enzyme cleaves DNA at defined position close to or within the recognition site. So these enzymes cleave DNA at defined site of 4 to 8 base pair in length. Most are homodimeric or tetrameric enzymes. So these enzymes do not use ATP for their activity. They usually require only Mg2 plus H cofactor. So they uses separate enzymes for restriction and modification, that is RNM system. The RM and the molecular weight is for these enzymes is 2200 kilodalton. The restriction sites of type 2 enzymes is palindromic, that is DNA or RNA sequence that reads the same in both directions. The type 2 restriction enzymes can generate two different types of cuts depending on whether they cut both strands at the center of the recognition sequence. The former cut will generate blunt ends with no nuclear overhangs. The latter generates sticky or cohesive ends. Thank you. That's it from my side.